Here is another brilliant question which can make huge difference between success and failure in a competitive exam. Let's enjoy the journey of learning. Let us explore how do we solve a problem related to geometry. This is a challenge question which can be seen in many competitive exams. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a very interesting question from past test papers, and this question has also come in some competitive exams. We are going to relate a semicircle inscribed inside a square and related with tangents. The question here is square ABCD has side lengths of a centimeter. A semicircle with diameter AB is constructed inside the square with the center at O. The tangent to the semicircle from C intersects the side AD at E. Find the length C to E. You can always pause the video, answer the question, and then look into my suggestions. Those of you who want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top. We can be part of your success. Let me also thank all the viewers and subscribers watching our videos, posting excellent comments and suggestions, and also to those who are contributing for quality education which we provide through our videos absolutely free in more than 80 countries. Great. Now let's try to understand. The diagram is already given to us. Let's see what do we need to find and how can we approach to solve this problem. We are given a square ABCD, right? Each length is A as shown here, right? A semicircle shown in light pink color is constructed with the center at O. The tangent to the semicircle from C intersects AD at E. So the tangent to the semicircle is at this point, which has been marked as P. We need to find the length C to E, right? That is what we want. Now, in this diagram, if I connect P to O, does it help us? Let's see. Now here, to solve this question, we need to understand a very important theorem. So that will give you a hint to solve this question. So let me provide you with the hint first. And the hint is that tangents from external point are equal in length. I should have written tangent segment. Now, what does that really mean? It really means that the length, so from C you can see, you can have two tangents to this semicircle. Can you identify those tangents, right? So we see that CP is one tangent segment and C to B is the other tangent segment. So these two segments should be equal. You understand? Because you see, they're tangent, right? This is tangent at this point, that is tangent at P. Now, if they are equal, and we know that C to B is A, so we can write this as equal to A. Makes sense? So we know that this part here is A. Same as the side of the square. So that part is clear, right? Great. Now, what is the remaining part E to P? So let that be X, right? We don't know what E to P is. But see, if you look at E, from E you can draw two tangents to the same semicircle. One is EP, right? Can you identify the other one? E to A, right? This is also tangent. So E to A. These are the two tangents from external point E to the same semicircle. And they should be equal. So let them be X. Now that becomes the base for solving this question. And now it is very easy, right? Now what can you do? You know the length E to C now, right? So E to C is basically X plus A, right? Or you can write A plus X. However, if you see the triangle EDC, what do you observe? It is a right triangle, correct? So that means you can apply Pythagorean theorem, right? So that means you can apply Pythagorean theorem. Makes sense, right? That is to say that CE square, which we really want to find, is basically equal to DE square plus DC square. Makes sense, right? So that is how you can actually find the solution of this particular question. Interesting. So what we have done for you now is brought you to a level where you can easily solve this particular question. Perfect. We are going to solve it now. But I hope you understand and appreciate our approach. It is not just giving you a solution, it is enjoying this journey of finding a solution. And that's why I say, enjoy the journey of learning with Anil Kumar. Perfect. Makes sense, right? That's what our students do. And simply, they are the best. So now let's get back to the algebra part of this geometry, right? Great. So we know that this length now is A here, and that is X. This is also X. And therefore, we can now begin with writing that EC squared should be equal to ED square. Let me write DE now, plus DC square. Now, E to C is a combination of X and A, right? So, X, let me write A first. It doesn't matter, I could write X also. A plus X whole square, right? Addition is commutative, no problems. D to E is basically how much? Now, this is A minus X, right? D to E, right? Because the other E to A is X, which we figured out, correct? So, it is A minus X whole square, and then we have D to C, which is A square. So we actually have taken up a general question. Now sides of the squares could be 2, 4, 8, 10, 16, whatever. But when I take A, I'm providing you with a general solution which will fit in any situation. Makes sense, right? Now let's expand this, which is A square plus 2AX plus X square. And on the right side, it is A square minus 2AX plus X square. And then we have plus A square. Makes sense, right? Bring all the terms together right? So what do we have? Well, we can cancel out some, right? And then bring them together. For example, this a square and this a square can cancel. X square can cancel with this. So we are left with what? We have to only bring this 2ax to the left side, right? Okay, great. So, so we have, let me bring it to this side. So we already have 2ax here plus this 2ax, right, is equal to a square. Now we can 2ax plus 2ax is 4ax equals to a square. So what is x equals to? X is equals to a square over 4a, right? Yes, I could have cancelled, simplified. Now I'll do so, right? So we get from here that x should indeed be equal to a over 4, quarter of the length a of the square. You get the idea. So this is 1/4 of this whole length. So the value of x is a over 4. What we need to find is the length CE, right? So let's find what is CE. So CE is equal to, as you know, a plus x. So a is a and x is a over 4. A is given to us, right? And this is equal to 4 plus 1, 5. A over 4. So slightly more than the length of the square, right? A quarter of its length more than the length of the square. Makes sense? So we now find the length of CE is 5a over 4. Perfect. So that is how we are going to solve this particular question. Perfect. So I hope the concept is absolutely clear. So let's summarize what we did here. So we basically utilized the two tangents theorem. So it is an application of two tangents theorem. We identified that this tangent from C and then that tangent will have the same length C to P and C to P, right? And that means this is A. And the other tangent we identified was from E itself. So from E to P and E to A, they also have the same length X. And that helped us to find the sides, finally, using the Pythagorean theorem. Perfect. So I hope this concept is absolutely clear. Now, this method of solving is actually utilized in many questions. So once you understand the strategy and the application of tangents theorem, you will be in a position to answer some very difficult questions in a competitive exam. I hope that all makes sense. Well, once again, thank you for your great contributions. These quality videos, which are helping students worldwide to be right on the top, are being possibly made with your support, right? So keep supporting us. Thank you and all the best.